So we're starting off our lesson today with just doing a review of pressure and pressure calculations. So let's do question number 4 here, which is calculate the pressure if 250 newtons of force is applied against a 10 meters squared of concrete. Express your answer in newtons per meter squared and in pascals. So we already know if it's in newtons per meter squared, the unit is also pascals. So the first thing we're going to do is pressure is what we don't know. Force, we do know. Our force is 250 newtons. And area we know as well. Area is 10 meters squared. All right, so our formula is here. Pressure is equal to force divided by area. So therefore, pressure is 250 newtons divided by the area, which is 10 meters squared. All right, and you can always just put this into your calculator. So 250 divided by 10, which is 25. So it's 25 newtons per meters squared, which is 25 pascals. All right, so that was just a quick review of pressure calculations because we will need to know those for the next part of our lesson for fluid systems. All right, so particles, they're always going to flow from areas of high pressure to areas of low pressure. So for example, aerosol cans, any aerosol products such as whipped cream, hairspray, shaving cream, they are under the gas particles are under high energy. So basically, when we take these high energy gas particles and we squeeze them inside these strong walled containers, they're going to exit through holes with great force. So if a liquid is present, the gas will push a fine foam or spray of the liquid particles as it exits. The openings are basically designed to help direct the spray. There's tiny holes for a fine mist or spray. There might be elongated nozzles for foam, such as in the whipping cream that we see. CFCs, these were chlorofluorohydrocarbons that used to be used in aerosols, but they were very damaging to the ozone layer. So they have been banned in many parts of the world. But aerosols are still very dangerous because the liquid gas is under so much pressure that high temperatures could cause the container to rupture or explode. Basically, what's happening is the high temperature causes the energy of the particles inside to become stronger than the container. And if it does explode, that rupture can cause contents to escape suddenly and with extreme force. There can also be an explosion. Puncturing or exposing aerosol cans to a spark can lead to an explosion. And gases under pressure are ready to expand because the particles have so much energy. And then if the gas is under pressure, they find a way to escape from a container, such as the nozzle or the hole, they will exit with a great deal of force. Fire extinguishers work a little bit differently than aerosols. The common carbon dioxide fire extinguisher, they contain a liquefied carbon dioxide. It takes up less volume than gaseous carbon dioxide. So when that liquid carbon dioxide is in cold temperatures, it exists as a liquid. And then when the fire extinguisher is turned on, the carbon dioxide particles, they gain energy and it becomes a gas. And a gas which needs a lot more space. So the carbon dioxide exits the tank with a great amount of force. The gas shooting out, it's still colder than its surroundings, and that helps remove heat from fire and extinguish it. The carbon dioxide will also smother the fire by not allowing the oxygen to continue combustion, because oxygen is required for the fire. So next we're going to look at hydraulic systems, and we're going to look at the Pascal's law. So hydraulics, this is the study of pressure in liquids, right? It's very important. Hydraulics is pressure in liquids. So a hydraulic system, that's a device that transmits an applied force through a liquid to move something else by means of pressure. So a force is exerted on a continuous enclosed liquid, and that applied force creates pressure. It's going to move the liquid through a series of tubes, pipes, or hoses, and that causes motion at the other end of the system. And this is based on Pascal's law, which says that an enclosed fluid transmits pressure equally in all directions. All right, so here this is a piston in the blue, and this here would be an enclosed container. And if the force is being applied downwards, pressure is being transmitted in all directions, equally in all directions. All right, so here is a diagram illustrating the principle behind a hydraulic lift, which is a device used to lift heavy loads. So this is a hydraulic system. So we have a piston here on the left side with a smaller area, and then we have a piston on the right side with a larger area. So by applying a force here on the smaller piston, we're able to create this larger force to lift up, for example, a vehicle. All right, and when we're working with these equations, it's important to note that pressure stays the same. So that's why P1 equals P2. Pressure will stay the same throughout this hydraulic system. F1 is the input force, F2 is the output force. A1, that's the area of the small piston. A2, that's the area of the large piston. So let's take a look at this example. So a hydraulic system has a small piston with an area of 0.5 meters squared and a large piston with an area of 4 meters squared. If 60 newtons of force is applied to the smaller piston, what is the total force pushing up on the larger piston? So first of all, let's label here on our diagram. A1, that's our smaller piston, and we know the area is 0.5 meters squared. So 0.5 meters squared, okay, that's the information we got from the question. And our large piston has an area of 4 meters squared. So here is our large piston, A2, and it is 4 meters squared. Next, we know that 60 newtons of force is being applied to the small piston here. So 60 newtons of force here. What is the total force pushing up the larger piston? That's what we don't know. We don't know F2. All right, so when we're working on these equations, we're going to do this in 2 steps. The first step is to calculate pressure. So step 1, we're going to calculate pressure. We know that pressure is equal to force divided by area. All right, so we know the force and we know the area of our small piston. So it's 60 newtons, and it's divided by 0.5 meters squared. All right, so we just put that into our calculator. 60 divided by 0.5, which is 120 newtons per meters squared, or 120 pascals. All right, so we have figured out our pressure. There's our pressure. And we know that the pressure stays the same. That's what we learned from the Pascal's law. So now if we know our pressure and we know our area, we can calculate our force. All right, so because we're looking for force here on the larger piston, force is equal to pressure times area. All right, we calculated our pressure. The pressure stays the same throughout this hydraulic system. The pressure is 120 pascals. So we're going to take 120 pascals and we're going to multiply it by our area. Our area is 4 meters squared for the large piston. All right, and then you're just going to multiply that out. 120 times 4, which is 480 newtons. All right, so our force or force, or F2, is 480 newtons. So basically, by pressing down with just a force of 60 newtons, we're able to lift up this vehicle or whatever is on this side by a force of 480 newtons. All right, so hydraulics to transport fluids. So liquids under pressure, they flow away from the applied force in all directions. So hydraulic systems can also be used to transport fluids over large distances. For example, water, natural gas, and oil. They're all transported in these extensive pipelines. And there are pumps as well that provide the force that pushes the fluid through the pipes. All right, so think about like apartment buildings and so on. How does all that water and everything else needed get up to the very top? It's because of these hydraulic systems. Why do traveling fluids need to be under pressure? They have to be able to travel up against gravity. So think about water traveling up to reach high-rise apartment buildings. There has to be enough pressure to transport the liquid over a large distance, but not enough to burst the pipes. So there is friction in pipes, just from the rough surfaces, or maybe there's lots of bends in the pipes, and that can affect fluid pressure. So particles, they lose energy as they brush past each other and as they bump into walls of pipelines. So those pumping stations, they restore the pressure that's lost on those long routes. All right, there is a quick video here on hydraulic machines. We'll watch that at the end. But lastly, I just wanted to talk briefly about pneumatic systems. So they're very similar to hydraulic systems, except gases are used instead of liquids. So hydraulic systems use liquids, pneumatic systems use gases. So it's an enclosed gas, which can then transmit a force causing motion. And it's based on the fact that gases can be compressed. So for example, compressors, these are devices that can compress air. The air pressure builds up in the devices, and then as pressure is released, the compressed air decompresses. So the particles, they start to move apart suddenly, creating a very strong, steady force that can perform powerful tasks. So heavy trucks and buses, they use pneumatic brakes, also called air brakes. Dentists use tiny precision drills, which are also pneumatic systems. And in construction work, for example, large tampers, which are used to pack down dirt and gravel when building a road. Those are also based on pneumatic systems. All right, so I do have a couple videos that I wanted to show. So I'm going to pause it here.